Okay, next we're going to calculate the empirical and molecular formula. This particular compound is in percentages also, but remember I stated you don't care if it's in grams or percentages. You just take that grams percent sign and change it to grams. So in this case, it's 43.7% phosphorus. So we'll just say that in a 100 gram sample, 43.7 grams of it would be phosphorus. And 56.3 grams of it would be oxygen. First step is always to change it to moles. I'm going to look phosphorus up on the periodic table of the elements and find out it has a molar mass of 30.97 grams in 1 mole. And remember, in order to cancel things out, you have to have the units on the bottom to cancel out the units on the top. So this next step is to put them into moles, and it is a division problem. To go from grams to moles, you divide by the molar mass. And I get an answer of 1.4110429 moles. Remember I said I'm going to drag around a bunch of digits in these particular problems just to make sure that I get close enough to that round number. And then this is 3.51875 moles of oxygen. The next step is to compare. When I compare, I'm going to pick the smallest number. The reason I'll pick the smallest number is so I don't end up with a decimal. Decimals can be harder for us to understand. And you can't have a part or a decimal of an atom. So we're looking for a whole number. So I'm going to pick this smallest number here and divide both of them by the same one to see how those numbers compare. This is obviously 1. And this one is going to be 2.5. Now remember, we said we can't have a decimal. So what I do here is I say to myself, for every 1 piece of phosphorus, there's 2.5 pieces of oxygen. But this doesn't make any sense because I can't have part of an atom. So what I want to do is multiply it by the lowest whole number that will give me a number that makes sense. So the empirical formula here is P2O5. Now, in order to get the molecular formula from this, I have to take the empirical mass, which is the mass of 2 phosphoruses plus 5 oxygens, and compare it to the molecular mass, which is 284 and was given to us in the problem. So we're going to go 2 times 30.07, 0.97, plus 5 times the mass of oxygen. And that gives us an empirical mass of 141.94. So again, now I have to compare this to the molecular mass. So remember, to compare, we divide. So the molecular mass is always going to be larger or equal. So we put the molecular mass on top. If the molecular mass and the empirical mass are the same, that means the molecular formula and empirical formula are the same. So 284 divided by 141 is going to give us about 2. In this case, which is not often in chemistry, about is okay because these are experimental data that come from pieces of machinery that do have sources of error. So the molecular formula is twice the empirical formula, is what this 2 means. So the molecular formula is P2O10. And that's my answer.